Good afternoon, everybody, and welcome to today's ARI Seminar. It's a pretty exciting day because we've got ARI people speaking for each of our presentations today, and we're going to start with the award-winning FAME presentation. So, woohoo! It's pretty exciting. These guys are pretty much fresh off a plane back from Seattle, where they won the Global Informs Award for decision analysis in practice. So congratulations to them, and it's a great opportunity for us to hear about that work and how we can properly integrate biodiversity in bushfire management decision making. So we're going to hear from Josephine and Nevil about that, and I know we've got Libby in the room as well, which is great. Tracy's away, I think. And then we're going to hear from Ivor about fishes in the Murray-Darling Basin. But we'll start with you, Josephine. Thank you.
Cool. From fire to water. We should have promoted that more. Yeah, thanks so much, Fern. This is not the Woohoo Informs presentation that we did as part of the Decision Analysis Practice Award, but it's the same project, but I've tried to make it a little bit more relevant to a local audience. So thanks so much for coming today and sacrificing potentially a lunch in the sun, which would have been nice. Our project was around applying decision analysis tools to make improvements in the consideration of ecological values in fire management. And in the past, this has been difficult. There's a diverse bunch of stakeholders with diverse perspectives about how to best consider ecological values. So we used a structured participatory approach to carefully tailor a workable solution to this complex problem. And the work I'm presenting today, as Fern mentioned, is a result of the combined efforts of Nevil, Amos, who's here, Libby Rump from Melbourne University, and Tracy Regan, who's in Hawaii. But also a big shout out to our, let's just see if it's gonna, there you go, woo! Big shout out to our regional fire risk and evaluation teams, who are essentially the core end users for our project. And they were terrific in testing the decision framework, providing feedback and guidance about what happens in the real world, so that we weren't just making this a theoretical exercise. And I'd also like to recognise the fantastic efforts of the Knowledge and Planning branch. They were essential in guiding this work and ensuring its kind of implementation. And also we had great input from a bunch of researchers from Uni of Melbourne and La Trobe, who brought their ecological modelling expertise and taxonomic expertise as well as colleagues at ARI. So unless you've been in some kind of media blackout, you're probably aware that we're experiencing another early start to the fire season. And in early September, there was already 135 fires that were active across Australia, which you can see on the right-hand side here. And this was predicted by fire forecasts, which you can see on the right-hand side, which shows above average fire potential across eastern and southern Australia. So it looks like longer fire seasons are the new normal. And we know from the 2009 and other big fires that the loss of lives combined with destruction of houses, and in some cases the destruction of whole townships, leaves impacts for decades after major bushfires. And the Code of Practice for Bushfire Management in Victoria states that preventing the loss of human life from bushfire takes precedence over all other considerations in fire management. But the associated objectives in the Code also reflect commitments to protect the environment from the impact of bushfires, along with that of human life, infrastructure and economy. And the second objective is to maintain or improve the resilience of natural systems to deliver biodiversity, water and carbon. And there couldn't be a better time to get our act together, because biodiversity is really taking a nosedive, and the recent biodiversity global report card looks worse than ever. We're in the middle of the 6th biodiversity extinction. There's over 1 million plant and animal species that are currently threatened with extinction if swift action isn't taken. But one of those actions we can take is to minimise the adverse effects of fire management on plants and animals so that we can ensure that we address both the sacred values of human life and the environment as part of our fire management decision making. Indigenous Australians, our First Peoples, have been managing the landscape with fire for over tens of thousands of years, and now we must also adapt to living with fire. And we know that many plants and animals, like this Banksia species, need fire to stay healthy. It requires fire to release seed from its woody cones. But each plant and animal has their own signature preference for fire. So like Goldilocks, too much fire or too little fire can be a problem. And this makes it incredibly complex. In Victoria, we've witnessed a strong legacy effect of a number of fires that occurred during the millennial drought. And the combined footprint of all these fires resulted in over half the area of native vegetation in Victoria being in a juvenile state, which is a big worry because this results in potentially irreversible changes in structure, function and composition. And then if you add in the additional declines in rainfall trends, we're seeing a massive decline in vegetation recovery. So considering this complex and emotive backdrop to deciding what's the best way forward to managing this bushfire risk and explicitly account for these trade-offs between human life and the decline and extinction of plants and animals. I'd like to step through some scenarios with you. So just starting off kind of simply, we have 3 scenarios where we have these different impacts on the potential impacts on the loss of human lives. So, okay, this one's a bit of a no-brainer. Let's try something harder. So in this second series, we have 2 sacred objectives. We've got human life and the loss of plants or animals. So just do a thought experiment. Which one of these would you choose? But importantly, how would you justify that decision to your stakeholders and make that choice? And what happens if we were talking about invertebrates versus an iconic species? All these things need to be factored into our justification for our choice. And just to make things a little bit more exciting, we can throw into the mix your risk tolerance to uncertainty. We might have 0 houses lost up to 100 houses lost for each of these scenarios. We might need to incorporate costs. There's a whole lot of multiple values that we're trying to optimise to make our decisions robust to the things we care about. So as I mentioned, there's been this major gap in ecological risk assessment for biodiversity. And so our work over the last few years was designed to bring ecological values back into focus for ecological risk assessment so we can meet legislation and community expectations. So the trigger for this project was really around, let's get better ecological data and modelling to improve the visibility of ecological values and decision making. But as part of that, we actually need a decision framework so we can get that wiring to make the science actually fit in the decision-making process, to make it work in the real world. So it's actually this overarching decision framework, which is the really kind of critical first step in making the data visible to this decision-making process. And the other aspect is that without a participatory approach, so without a whole bunch of end users and different people who are interacting with the decision involved in defining and providing feedback on this decision framework, the end result won't work. So I'd sort of see there's 3 kind of pillars. There's the participatory approach, there's the decision framework, and then of course for that to work, you need the ecological data to inform it. So we had quite a bit of participation, and this just runs through a few of the workshops that we were involved in. And as I mentioned, the regional plan burning biodiversity officers, we road tested our project over the last 2 years at their quarterly meetings. But there was a whole bunch of other workshops where we did objective setting for strategic bushfire management planning. We looked at significant impact thresholds for EPB's listed species, looked at methods for trade-offs, as well as thinking about, well, how do we deal with uncertainty in our data and models and tools? So this is essentially the decision framework. So it comprises a series of steps, starting with defining the decision problem. What's the context in which we're trying to use this information? And then articulating the objectives for that decision context and providing performance measures that represent those objectives and values. The third step is around identifying the alternative management action. So how much fire we're going to put into the landscape. The fourth step is the evaluation of the consequences of our alternative fire management against the objectives that we care about. So this was the component that was the kind of trigger for the project around improving critical data and modelling gaps. Fifth step is about, well, how do we make trade-offs? It's often the case that we can't simultaneously optimise for all the things that we care about in a decision. So we need to make trade-offs between the values. And then finally, how do we update our decision in light of uncertainty in our information? We might have knowledge gaps, but do they actually matter for the decision at hand? So, like all decision therapists, we jumped into our first workshop and we were like, come on, tell us your problems, what's going on here, what's the worst thing that could happen, what's the best thing that could happen. And this was really useful in highlighting what are the issues with the decision-making process versus what are the technical issues with the models and data. And so if we just jumped in straight with assuming that data was the end of the story, we would miss this other side of the story. And so I think the other part of this process of setting the decision context is it's also really useful to collaboratively define, well, what's the scope of the project? And what are we feasibly going to address within the resources of our 2-year project? So as part of the decision context, we needed to understand who are the decision makers, and they are working towards different drivers and expectations from a regional DELT point of view compared to a statewide decision-making perspective. There's a timescale of the decision. So often there's a tension here between a management timescale, which is over sort of a shorter period of time, versus an ecological timescale, which is over a much longer period. So how do you specify your decision to represent this sort of longer timescale, which is more meaningful for biodiversity? And then consideration of the spatial scale. So when we talked about this project, there's 3 tiers of planning. There's a statewide level of planning, there's a regional level of planning, and then there's the fire operations plan, which is at the burn unit level. And given the size of the problem, we needed to make it tractable. So we focused our effort just on the strategic bushfire management planning scale, recognising that there are these other decision contexts that sit around that work as a starting point. And also, just as we started our project, there was a desire to go cross tenure, so consider public land as well as private land. But again, given the data sort of limitations on private land, we needed to make our project tractable, so we just looked at public land as a first step. So we knew from the Tell Us Your Problem session that the objectives that were sitting within the Code of Practice for Bushfire Management of Public Land weren't that sort of tractable when making decisions. So we asked people to say, well, what do you actually care about when you think about ecological values? And we got a whole bunch of things that came up. And we asked people, well, why do you care about that? And we kept on asking them, why do you care about that? Being really annoying, but we got there in the end. And it actually turns out that there's only these 3 sort of simple areas that people fundamentally care about. So ecosystems, plants, and animals. But there is some nuance there in terms of we might care differently about threatened species or iconic species in terms of making a decision and making trade-offs. So just to give you an example of one of the objectives that we came up with in our workshops was that, just to take a step back, considering that the objectives weren't working historically, we used this set of criteria to help us really ensure that these objectives were robust to the decision-making process. And a big one was, were they understandable? Because if they're not understandable, they'll basically be put to one side in the decision-making process. And so an example that we came up with is minimise decline and persistence of all plant and animal species. So that's our objective. And historically, we had decline in the geometric abundance of all plant and animal species from a 30-year baseline as a performance measure. But this is a biodiversity index, and when you're making trade-offs with number of houses or address points lost versus a biodiversity index, it's actually kind of quite hard to do from a decision maker's point of view. So there was a preference for an alternative specified performance measure, which was the proportion or number of significantly impacted plant or animal species. And to ensure that that performance measure wasn't ambiguous, we needed to specify, well, what's significantly impacted? And that is essentially a value but judgment about how much you're concerned about declines in species. And it might be you're concerned more about an endangered species declining than something that's not threatened. And another part of the story, which is you'll see here, is that all the 5 fundamental objectives that we elicited through our workshops all talk about avoiding decline, which I think reflects the risk appetite of our end users, is that people are more adverse to declines than they are to increases. But we recognise that actually some stakeholders think that that's kind of selling yourself short, that we might actually need to talk about maximising increases of plant and animal species. So I guess we recognise that this is an area of further work that should be considered. I think as a starting point, we've at least got a set of performance measures that the regions are using and that they've been able to share those with the decision makers, and they're much more visible than historically was the case. And so over to Nick. Thank you. Cool.
Okay, so for those 5 key objectives that Josephine just mentioned, there are a range of metrics which fall under those, probably 14 different metrics which we needed to be able to provide to the end users. So my job was dealing with the technical issues around these, and what the, how do we make this go forward? Frustrations around some of those technical issues. So we had numerous different ecological risk assessment methods which had been used to a certain extent in different regions in the past. Many data sets, some of them stored locally, some nobody quite sure where they were stored anymore, and so on. So initially part of the work was just getting together all of the data we could and developing a standard approach agreed with our end users, which they could then customize and choose which of the metrics they were interested in for their particular region. Other parts of the problem were that the whole process, where it had occurred before, was very time consuming and involved a lot of detailed technical knowledge in GIS and coding. The outputs were very different, and basically it hadn't been done for large parts of the state, but even bringing together the data from different parts of the state where an attempt had been made at measuring the ecological outcomes of planned burning were difficult, because the measures used in each region were different. The work took a very long time, probably 7 weeks or more to go through for one region, and was dependent often on costly licensed software. So we wanted to boil things down to a set number of metrics and be able to present those in a way which was easily understandable and didn't require the detailed coding and technical knowledge. So the main thing we wanted to do was provide, make this whole thing more visible and easily usable. So we needed a name which people wouldn't forget, and the name chosen was FAME, a Fire Analysis Module for Ecological Values. What does it do? Well, it addresses a lot of the technical issues. It provides an easy user interface which our end users can operate on either custom data sets which they provide as an input, or they can use standardized statewide data sets if they don't have different or preferred local data. It's accessible via that interface without having to do any coding, and it allows all 14 of the metrics to be produced for any given specified region. it's written in open source, so in R.
There's a bit of animation
Yeah. So one of the major issues we had was the speed of doing these analyses previously, which were all largely done in vector format in ArcGIS, making the process very slow. So by putting all of our varied data sets into arrays in R, we were able to deal with the multiple dimensions of the species, the different fire regimes, time since fire, vegetation type, and space in those arrays, and allow us to greatly increase the speed of calculation. So analyses which previously took weeks and a lot of hands-on work were possible in a few hours. This also allowed evaluation of multiple scenarios, whereas previously at best what we had was a fire management plan would be developed, and the consequences of that fire management plan on some aspects of biodiversity, ecological values would be evaluated. But because of the time to do it, it was just done once, and okay, you'd say these are the consequences. You wouldn't then be able to trade off consequences with different alternatives. So the module works in the following way. There's a utilities part to it, which allows upload and download of the data sets, so upload of specific data sets from the region and download of the results from the web interface. Then the first part is in all cases is evaluation of the fire scenarios, which is one of the more time-consuming parts of the analysis, which allows you to calculate spatially everywhere the time between each of a sequence of fires at the location, the time since the last fire, and relate that to the vegetation at the site. Importantly, it uses exactly the same spatial input as Phoenix Rapid Fire, which is the tool used for simulating the impacts on life and property in fire planning in Victoria, so that our results were directly comparable with that. It allows you to select your ecological objectives. So from those 5 fundamental objectives and 14 performance measures, you can pick which ones you want to use. You can pick whether you want to do it for all species in your region or whether you've got a certain number of iconic species. You can also weight species differently, either on the basis of their threat status or their abundance in your region compared to their abundance elsewhere in the state. So you can customize that part of the work and provide a simple drop-down menu input in FAME to get the outputs you want. You can then visualize the results and explore those results. And lastly, there's an option for some optimization of results. This last stage is a separate piece of work, which currently works on aspatial optimization, whereas the rest of the tool is spatial. So just as a couple of examples of the results we get out of this, this animation here is showing the vegetation of the Central Highlands over a 40-year time period, and showing the areas which are too young, which is below the tolerable fire interval for the vegetation, which is the period, which is the age at which there are key species in that habitat which won't have reached reproductive age and so are less resilient to fire. If there's another fire in that period, you may well lose species from the area. Versus those which are potentially too old, which is a somewhat more difficult to define character, but where at the other end of the thing, you're having species which are lost from the seed bank past a certain age and just right. In the Goldilocks theme are the areas which are within tolerable fire intervals for that vegetation. As you can see, over that period, there's a big changes as a result of some of the major bushfires, but also of some plant burning in the area. Another thing you can look at is changes in, again, this is the Central Highlands, so this is changes in relative abundance. Because we aren't able to actually measure the abundance on the ground, we use habitat suitability combined with the time since fire in a simple model to calculate likely abundance of particular species in the area. This is a model of greater glider abundance following both past fires and, in this case, looking at potential future bushfires under a climate change scenario. Okay.
Right. So yeah, just to finish up, Nev has done some great work in developing this module, but we needed to test it with some real scenarios. So as part of strategic bushfire management planning, we worked really closely with 3 of the regions to test their the consequences of their alternative fuel management on biodiversity. And then we used a couple of different measures to explore trade-offs. So first of all, doing a qualitative investigation of trade-offs between life and property and biodiversity, and then using a process of quantitative ranking with swing weighting as well. So for the project outcomes, as Nev mentioned, we've managed to save huge amounts of processing time for undertaking ecological risk assessment. We've got some practical guidance about, what are good objectives, how do you actually implement them in a decision-making process and as part of a trade-off assessment. And we've been able to undertake training across the region with our regional risk assessment teams to use FAME and also use the tools in the decision analysis framework. So lots of really nice feedback, and it's been so satisfying to address some of these long-standing problems around consistency and transparency and consolidated data and standardised metrics. So from a personal perspective, I'm really pleased that we were able to get improved uptake of research. I think research has been really good, but we haven't been able to connect with the decision-making process. And I think that these structured participatory methods are the key ingredient to make that happen. It takes a lot of time, but I think it's time well spent because we've been trying to tackle this ever since I've been here at ARI, incorporating ecological values in fire management, and I think this has given us the best chance yet. I think we've got to recognise that there's no right way forward because this is essentially intersection of people's values as well as technical information, but by drawing in this participatory approach and the wisdom of the crowds, you can arrive at a reasonable way forward that addresses people's sort of expectations within that decision context. So yeah, that's pretty much it. But look, huge thank you to everyone who's been involved across a number of different agencies and parts of the department and universities and Parks Victoria. And thank you everyone for listening.